We now move to Norway, to Oslo Metropolitan University, to Kyrre Begnum. I hope I've not mispronounced your name. He is the Associate Professor at the Faculty of Technology, Art and Design at the Department of Computer Science, Oslo Metropolitan University. Welcome.
Thank you. Can you hear me all right?
Yes.
All right, fantastic. Let me start my presentation. 1 second. There we go. So good evening, everyone, and hello to all my Scandinavian neighbors. It's very interesting to hear about all the other offers, and I can tell that there's a lot of overlap in the topics that we cover. So as already presented, my name is Kyrre Begnum, and I am a member of the faculty that teaches in this one master program that I'm going to present now. This is for Oslo Met, or Oslo Metropolitan University. So we are right in the middle of the capital of Norway, and that would be the city of Oslo. So we have one master's program within technology that is called ACIT, which stands for Applied Computer and Information Technology. And that is the program that I want to tell you about. So it is a 2 years international master's program, and international means that everything that we do happens in English. Even Norwegian students who come to this program also have to do everything in English. So we try to make this as inclusive and international as possible. Around 50% to 1/3 of the students are from all over the world, and then the others are typically from Norway and or EU countries. The interesting thing about this program is that it offers several specializations within this one program. So it's a rather large and broad single master program, as opposed to having several different master's program that share courses. This is one very large program instead. So this also means that students from many different backgrounds can apply, such like computer science, electrical engineering, mathematics, physics, and mechanical engineering, and so on. So I will try to make an analogy of how this program is designed in a second, but I just want to talk a little bit about what we try to achieve with the program. As already mentioned, I'm one of the individuals teaching in it, so I do have a certain opinion about what it is that we try to do. So first of all, many of us from Oslo Met, we do have industry experience as well. And we understand that for a career in technology, one sometimes need more than just being an expert in a single field. In fact, in most cases, you will be an expert, but you will have to work with other experts from other fields as well. And this interdisciplinarity, I think, is becoming increasingly important as a part of the study as well, so that your master's is not only in expert training, but also training in coping as an expert together with other experts who are experts in different things than you are. This is what we typically get back as a feedback from our industry partners when we have seminars with them in order for them reviewing our course material and so forth. So we've taken that to heart, and we therefore designed the program like that. So experts within interdisciplinariness, if you will. Also, we do have a lot of research groups at our university, and every research group essentially is connected with one of the specializations within the master program. And we also have collaborations with industry actors in the Oslo region and also other places in Norway. So if you would compare this image with what we try to achieve with our program, then this would not be a correct representation, in that our goal is not to create every student as a similar, identical individual when they graduate. Now, if students are interested in this, there are many very good alternatives that go very deep on a single subject, but we have actively, purposefully added interdisciplinariness into our program. in order to avoid this. On the other hand, also, we don't want to achieve this, where all students know so much of everything that they don't know enough about anything, and thereby makes them too general for them to be useful as an expert. So obviously, this is also something that we are avoiding in our program by design. Instead, if I could make the cheesy analogy, it is obviously this that we're aiming for, and that is the appreciation that success in the industry is often from teams that are interdisciplinary, but are able to collaborate, and where the synergy of their collaboration is in fact desirable. And this is what we try to achieve within the program, and not leaving it up to you when you graduate. Let me I do apologize for this analogy. I know it's a bit cheesy, but I think it's the best way to explain what we want. Let me go through the list of specialization. So we have Universal Design of ICT, which is one of the specializations. And in Norway, as increasingly other places in the world, universal access to computer systems is now being regulated by law the same way that we would regulate universal access into, let's say, buildings and so on. And as such, this is the only specialization track in Norway that has this as a focus. So it is very attractive for Norwegian as well as international students to come into this specialization, because it offers a very unique and highly sought after specialization that is very desirable at the moment. And as these laws are adapted throughout Europe as well, we see more and more focus of this kind. Another specialization is data science. Now, this, I think, is similar to many other data science tracks in the sense that it offers computation with statistics and applications of such in a so-called, let's say, in between of mathematics and computer science, if you will, or statistics. We also have cloud-based services and operations. So this would be a specialization that is dealing with agile software development, automation such as automated testing, cloud-based systems, and so on. So many students who take this track typically go out into developer roles, or as so-called DevOps specialists in the industry later. We also have Biomedical Engineering, and this would then deal with things such as artificial heart valves and or means of measuring, let's say, heart rate and blood sugar levels and so on. It's still within technology. It's very interesting to see the cross-pollination across these specializations and some of the others. Then we have applied artificial intelligence, and this would be one of the specializations that, like in many of the other Scandinavian examples, addresses artificial intelligence, but here we still keep a very applied focus and look at how the different approaches within artificial intelligence are used today. And I'll give you an example in a second of where this was used. Now we have Robotics and Control. This group recently opened another lab called Oslo Met Ocean Lab, which is right at the waterfront of the Oslo Fjord, so the water inlet that leads to the city of Oslo, where they are currently working on underwater vehicles as well as drones. Then we have mathematical computing, mathematical modeling and scientific computing. And this research group just recently got the first quantum computer in Norway, which they are going to reveal live on YouTube in a bit, in fact. So you can thereby see that for each of these specializations, there is a local research group of between 5 to 10 researchers and faculty members, and then additionally some PhD students. So even though we are, I think, the third largest university in Norway, compared to many other places, it is still quite local. I mentioned in the beginning how we force interdisciplinariness into this program, and I want to show you one way this is done in particular. And that is, we have a model that we call a 3+1 model. And this means a little bit like the American major and minor model for educational programs. When you apply for the program, you apply for a specialization. And when you get accepted to that specialization, that forms the core of your expertise, if you will. However, in addition, we do require that you, 1 year into the program, also take one of the specialization courses belonging to one of the other specializations. So this means that even though we have elective courses and offer, more opportunities to go deeper, we do actually force you to actually dip the toes in the water of one of the other specializations. And the combination here is a little bit up to you, but you can already tell that most of the combinations are very interesting. For instance, you could have robotics and then have your +1 in AI, or you could have biomedical engineering and have your +1 in universal access, or you can have mathematical modeling and scientific computing and have your +1 in a cloud, for instance. So as you can see, these combinations are something that you don't have to determine when you start. We wait until you have spent 1 year at the program and become an expert in your own field. At that point, you probably know more of what you would want to know more of, and that is when you make the +1 choice. So this was the example I alluded to earlier that I wanted to bring forth. These are 4 students that I'm very proud of, and they attended a hackathon that was a collaboration between a Norwegian company that was dealing with wastewater management in the connected to the Oslo fjord. And they were dealing with some issues in floodwater management, so how they would deal with rapid floodwaters into their systems, and that essentially forcing them to dump wastewater into the fjord. And they invited students from different schools to participate, and this group won the hackathon, and this was the group of our students. But what's significant about this is that from left to right, Sergio, he was part of mathematical modeling. Marit, she was a member of the AI specialization, and Ola was member of data science, and Petter at the end, he was robotics. So already within within their study experience, they already formed a group where they all were from different specializations, yet they were able to collaborate and participate in a hackathon and win it. It's not just that they won that's important, but the fact that students from different fields already learned to collaborate, I think, is one of the biggest assets of our program. A couple of practical things at the end. We offer long and short master thesis. A short master thesis is 1 semester, that's at the end. The long master thesis corresponds to 1 year of work, but is actually stretched out over 3 semesters. There is a focus also on research communication and interdisciplinary innovation. This is handled by mandatory courses for all students. This is where I teach at the moment. So we do focus a lot about how to read research, how to understand it, and how to communicate research, not just academically, but also for a popular audience. We do have close industry connections, as the hackathon, I think, displayed. We often have guest lectures, and we often have close connections to other companies nearby that want to have master students for their projects, but also want to collaborate with us on research. The application deadline is 10th of December, so it's earlier than some of the other cases that I've seen here, but I'm very happy to announce that we in fact don't have any tuition fee in state education in Norway. So the only fee that students pay here is the, I think, closely compared to €100 regular study fee that all students pay. There are, though, some financial requirements when you apply for a visa, but I would suggest you go and seek up more official information about that. If you would have any more questions, feel free to follow this link, which I'm sure none of you will be able to catch quick enough, but the fastest way to find our program is just to Google Oslo Met and ACIT, and I'm pretty sure that our program will be the top hit. Tulpash here is our current head of the program, and you can reach him with the email address tulpash.patel@oslomet.no. So thank you very much for your attention.